Good evening, Samita. Good evening, Sriyuta. Good evening, all. All of you are getting my voice or not? Samita, are you getting my voice?
Yes, sir.
Sriyuta?
Yes, sir.
Right now. In last class, we are discussing about the classification of the organic compounds. Is it right? So, in that one, up to we discuss about here, we are discussing about the homocyclic compounds. So, what is meant by the homocyclic compounds means here? In a cyclic ring, if the carbon are only carbon atoms are there, means that we can call as a homocyclic compound. Okay, heterocyclic compounds means here in a cyclic ring, one carbon atom is replaced by other atoms, either it may be oxygen, nitrogen, or sulfur is called as a heterocyclic atoms here. What are the examples of the heterocyclic atoms and all means here? Heterocyclic is furan, tetrahydrofuran, thiophene, pyridine, pyrrole. So all these are the examples of heterocyclic compounds. Again, homocyclic compounds. Homocyclic compounds are classified into two types. How many types it is classified here? It is classified into two types. So one is alicyclic compounds and another one is aromatic compounds. Okay, alicyclic compounds are nothing but here aliphatic saturated hydrocarbons. Okay, cyclic compounds are we can call as a alicyclic compounds. Aromatic compounds. So what is mean by the aromatic compounds, which we can call as a aromatic compounds means here aromatic compounds are nothing but so here again aromatic means actually aroma means it is a Greek word. It is a Greek word. So the compounds which gives the pleasant smell. Okay, the compounds which gives the pleasant smell is called as a aromatic compounds, which we can call as aromatic compounds means here the compounds which gives us a pleasant smell is called as a aromatic compounds. Okay, now again aromatic compounds are classified into two types. How many types it is classified? Aromatic compounds are classified into two types. So what are the two types of the aromatic compounds we are having means here? Benzenoids and non-benzenoids. Non-benzenoid. Sir, first of all, what is mean by the aromatic compound? So this is an important concept, ma. Actually, again, compounds are classified into three types. Okay, aromatic compounds, non-aromatic compounds, and anti-aromatic compound. Sometime based on this one, they're asking the question. First, we'll discuss about what is mean by the aromatic compounds. Aromatic compounds. What is mean by the aromatic compounds? What we can call as aromatic compounds. Aromatic compounds are nothing but here the compounds which are having pleasant smell is called as aromatic compound. Okay, and the compounds which burns with the smoky flame or sooty flame is called as aromatic compound. Sir, what are the characteristic properties of the aromatic compounds? Mean to exhibit the aromaticity, compound it has to follow the three rules. One. How many rules it has to follow here? Three rules. So what is the first rule means here? Compound it has to be planar structure. First rule is here compound it has to be planar structure. Okay. Second rule is compound it has to be conjugation. What is meant by the conjugation? What is meant by the conjugation? What is meant by the conjugation? Conjugation is nothing but alternate single bond, alternate single bond and double bond. Alternate single bond and double bond. Okay, or charge also we can take. So like that it is that means that we can call as a conjugation. Second condition, compound it has to be conjugation. Third condition is it has to follow the Huckel rule. It has to follow Huckel rule. Sir, what is meant by the Huckel rule? Means it has to follow 4n plus 2 pi electron rule. Okay, 4n plus 2 pi electrons rule it has to be followed. In this one, N is equal to 0, 1, 2, 3, 4, 5, like this it will be there here. For example, if N is equal to 0 means how many electrons it has to be there here? The total number of electrons. If N is equal to 0 means 4n plus 2 means how many electrons it has to be there? It is having only 2 pi electrons only now. How many pi electrons it has to be there? 2 pi electron. If N is equal to 1 means how many pi electrons it has to be there? Total 6 pi electrons it has to be there. If N is equal to 2 means how many pi electrons it has to be there? 10 pi electrons. 10 pi electrons. Okay. So here, if the N value is going to be increases, means number of electrons also is going to be increases. Okay. So to make you clarity, so what is the best example for the aromatic compound? So what is the best example for the aromatic compound? Best example for the aromatic compound means we can write as a benzene only now. We can write as here benzene. Sir, what is the molecular formula of the benzene means? C6H6. Okay, so benzene is containing total how many carbon atoms and how many hydrogens means it contains the 6 carbon atoms and 6 hydrogen. In 6 carbon atoms and hydrogens are present in a one plane, then only we can call as a planar. Okay, if all atoms are present in a same plane means that we can call as a planar structure. And conjugation means if you see means, so it is having alternate double bonds. It is having here alternate double bonds. So let us see single bond, double bond, single bond, double bond, single bond, double bond. It is there. So now we got the clarity. Okay, that is only whenever it is having the single bond, double bond, single bond, double bond means that is only we can call as a conjugation. And Huckel rule. So what is meant by the Huckel rule means which it contains the 4n plus 2 pi electrons. Okay. Now in this one n value is equal to 1. Okay, sometimes n is equal to we can consider as a number of cyclic rings. So benzene is containing how many cyclic rings means it contains here only one cyclic ring. If it is only one cyclic ring means if n is equal to 1 means total how many electrons it has to be there here? Total 6 pi electrons. Either the given compound is having 6 pi electrons or not. Whether the given compound is having 6 pi electrons or not, ma? How many pi bonds are there? Srita. How many pi bonds are there? The number of pi bonds. It has 3 pi bonds. How many pi bonds are there? 3 pi bonds. 1, 2, 3 are there. So 3 pi bonds are there. In the formation of the one bond, so 2 electrons are required. How many electrons are required? 3 electrons. Then 3 into 2 pi electron. The total number of electrons is equal to 6. That means third condition also it is satisfied only now. So the given molecule is first of all it is having the planar structure. Second condition is conjugation is there, and third one it follows the Huckel rule. When all these conditions are satisfied, mean then the given compound is called as an aromatic compound. Okay, I'll give one more example to you to make you clarity. Okay, so what is another example means here? I'm giving as a naphthalene. Okay, naphthalene. This is the naphthalene structure. Is naphthalene is an aromatic compound or non-aromatic compound, ma? Once you check it out, this we can call aromatic. As aromatic. How you are telling that it is an aromatic? How you are telling the aromatic, ma? First of all, it has a planar structure. First condition is satisfied. Okay, and naphthalene is having alternate single bond and double bond. Second condition is satisfied. And what is the third condition? Third condition is 4n plus 2 pi electron. In this one, n value, how much we have to take? We have to take n is equal to 2 because it is having 2 cyclic rings. If 2 cyclic rings means n is equal to 2. If n is equal to 2 means how much will get us here? 10 pi electrons. Either it is having 10 pi electrons are there means 5 pi bonds are there. While having the 5 pi bond, 5 into 2, total you will get as a 10 pi electrons. Got the clarity?
Yes, sir.
Okay. So this support the aromatic compound, and all these are benzene and naphthalene are having here benzene like structures. Hence we can call it as a benzenoid. And one more example I'll give my exam point of view question here. I'll give here. This one. Either the given compound is aromatic or non-aromatic. whether the given compound is aromatic or non-aromatic. Sir, what is
Non-aromatic.
what is the non-aromatic means here? Out of three conditions, if one condition also is not satisfied, means that we can call as a non-aromatic. Okay. Now, so the given compound is aromatic or non-aromatic? These two examples.
I think it's non-aromatic, sir.
Non-aromatic, but Samita, it is the aromatic compound.
Sir, the second one, the triangle one.
Triangle one also.
How, sir? There's no alternating single and double
Actually,
bond.
it is MSET level question. First one MSET I had seen last time. MSET question this one. MSET paper also you can check it. This kind of questions are there. That is the first one. First planar structure, cyclopentane. Cyclic rings are having planar structures. Point number one. Second one. Conjugation is there. Charge, single bond, double bond, single bond, double bond, charge. Okay. Now, so conjugation also it is there. In both the cases, in this also positive charge, single bond, double bond, single bond, charge. So both are having two conditions are satisfied. Third condition only will get that out here. So in this one, for cyclopentane, n value is equal to 1. For cyclopentane, n value is equal to 1. If it is n value is equal to 1 means, let us see ma. So total how many pi electrons it has to be there? Total 6 pi electron. Sir, already 2 pi bonds are there. So 2 pi bonds means we are having only 4 electrons only. Then what about the remaining third pi bond? So third pi bond is nothing but here we have a charge, negative charge is there. So when we'll get up the negative charge means while having the 2 unpaired electrons. Okay, while having here 2 unpaired electrons here. Okay, 2 unpaired electrons. That is only pair of electrons we can call. So what we can call that we can call as a pair of electron. When it is having the pair of electrons, that 2 electrons also we have to consider. Okay, that negative charge also we have to consider. So 4 plus 2 total number of electrons is equal to 6. Then the given molecule is aromatic. But in this one, n is equal to 0. N is equal to 0. If n is equal to 0 means the total number of pi electrons it has to be. How many pi electrons it has to be there in a given compound? How many pi electrons it has to be there, ma? The given compound it contains here 2 pi electrons. Whether the given compound is containing 2 pi electrons or not? Samita. Whether the given compound is containing 2 pi electrons or not? Then the given compound is aromatic or non-aromatic?
Aromatic.
Aromatic. Now we got the clarity?
Yes, sir.
Okay, and benzenoids and non-benzenoids, one statement I had given. Again, aromatic compounds are classified into benzenoids and non-benzenoids. Okay, now in this one, my question is, which are the benzenoids and which are non-benzenoids? Both, all are aromatic compounds only, as per you. Naphthalene and benzene they are called as a benzenoids because of they are having benzene-like structures. And cyclopentene carbene ion and cyclopropene carbocation are non-benzenoids because of they are not having benzene-like structure. Got the point?
Yes, sir.
Okay, ma. So next one. What is the important point we are having means here? Next, we have a homologous series. Some important, simple basic terms are there here. So what is that the next concept means here? Homologous series. Homologous series. So what is mean by the homologous series? What is mean with the homologous series means here? A series of compounds or a group of compounds which are differentiated by one CH2 group or 14 grams by mass is called as a homologous series. Let us see, ma. For example, first I'm writing as a methane CH4. Next I'm writing as a CH3 bond CH3 that we can call as a ethane. Methane and ethane are differentiated by what's the difference between the methane and ethane? Methane and ethane are differentiated by. So what's the difference it is there in between these two?
There is a CH2 extra.
One CH2 group na, and one other one. ethane and propane, CH3 bond, CH2 bond, CH3. Once these two are differentiated by CH2 group only na. Now all are having same molecular, some general formula is same. They have a similar chemical properties. The compounds are having here similar chemical properties, but are differentiated by one CH2. What is the molar mass of the CH2 means here? 14 gram. If the differentiated by 14 grams means that also we can call as a homologous series. Okay. Next, functional group. What is mean by the functional group? What is mean by the functional group? What is meant by the functional group? So what is meant by the functional group means here? Functional group is nothing but a group of atoms, which are responsible for chemical property of the compound. Chemical property of the compound. Okay, a group of atoms which are responsible for chemical property of the compound is called as a functional group. Sir, what are the functional groups we are having? We have different types of the functional groups here. Okay, so what are the different types of the functional groups we are having means here? One is carboxylic acid. Okay, second one is here sulfonic acid. Next one is acetic anhydride. Okay, anhydride. Ester, acid chloride, amides, cyanide, isocyanide, okay, and aldehyde, CHO, ketone, C double bond O, alcohol, thioalcohol, ether, amine, and H2. So all these are the different functional groups we are having. Sir, what are the functional? I wrote as here, all are the decreasing order of the priority. Okay, this is the decreasing order of the priority. Sir, sometimes they are giving us a different functional group. So what is the priority order of the functional group means here? This order we have to remember. So which one we can give as a first priority, ma? So what is the first priority of the functional group? Carboxylic acid. Second one, sulfonic acid. Third one, anhydride. Fourth one, ester. Fifth one, acid chlorides. Sixth one, acid amides. Seventh one, cyanides. And this also we can call as a nitriles also. This also we can call as a nitriles. Eighth one is isocyanides. Ninth one is aldehyde. 10th one is ketone. 11th one is alcohol. 12th one is thioalcohol. 13th one is ether. 14th one is amine. So all these are the functional groups. This order we have to by heart. Okay. So sometimes they are giving us a different functional group. They're asking, write the increasing order of the priority of the functional group. So where it is going to be useful for us means here while writing the IUPAC nomenclature. Okay. So IUPAC nomenclature, based on the IUPAC nomenclature, conformly, they're asking 1 or 2 questions. How many questions they're asking, ma? They're asking 1 or 2 questions conformly. Okay, so IUPAC nomenclature is very, very important. Okay, so just I'm going to explain the rules and regulations only. Okay, and I'll explain 1 or 2 examples here. Okay, I'm going to explain some two, three examples to you. Okay, so which are having more than one function group. Let's see. First, I'm taking let's see some example. Here, CH3 bond, CH2 bond, CH bond, OH bond, CH2, COOH they had given. For example, they had given this one. Okay, the given molecule is containing the 2 different functional groups. How many functional groups are there here? 2 different functional groups are there. So one is carboxylic acid, another one is the alcohol. Okay, 2 functional groups are there. Now, sir, while writing the IUPAC nomenclature, first what we have to do means here, first point number 1. So we have to select the longest chain. First condition is we have to select the longest chain. You can select any direction, but the longest chain, it has to contain the maximum number of carbon atoms. Okay, so the longest chain, it has to contain the maximum number of carbon atoms. Second point, after finding out the longest chain, substituent we have to find out. So what substituents are nothing but branched chains. Substituents are nothing but here branched chain. Second condition, we have to find out the branched chains. Okay, and third condition. So what is the third condition? Means numbering. Substituent has to get as a least numbering. Substituent has to get as a least numbering. Fourth condition. So what is the fourth condition? Means here, while giving the numbering, if the given compound is containing the functional group, means according to the priority order, the functional group which is having first priority, for that one we have to give the least number. Okay, according to that one. Let us see, either we can give the numbering from right to left or left to right, ma. How we can give the numbering?
Right to left.
Very good, Srita. Okay, so from which direction we can give? Means here right to left. 1, 2, 3, 4, 5. Okay, from right to left we can give the numbering. So okay, in root word total, how many carbon atoms are there? 5 carbon atoms are there. In a parental chain total, how many carbon atoms are there? 5 are there. And then alcoholic group, it becomes as a substituent. Alcoholic group, it becomes as a substituent. So what is the substituent means here? So we have to write as a prefix. What we have to write means here, we have to write as a prefix. Sir, here, what is mean by the prefix of the OH group? Means here hydroxy. What is the position of the hydroxy? Means here 3 hydroxy. 3 hydroxy. Root word is containing 5 carbon atoms. Then root word you will get as a pen. Given compound is saturated. Saturated suffix is "ane." In this one, E is replaced by the secondary suffix. Sir, what is the secondary suffix? Means here carboxylic acid. Hence we can write as a oic acid. So what is the given name of the given compound? Means here 3 hydroxy pentane 1 oic acid. Got the clarity? Okay.
Yes, sir.
So IUPAC nomenclature is very, very important. Actually, it is not possible to complete the IUPAC nomenclature even one day. Okay, so many rules and regulations, so many exception cases are there. So when you're practicing, once you read your NCERT, just don't. So once you read Academy or whatever the books you are providing here, okay, for MSET level, that is enough. First, you read the rules and regulations and you practice the questions. So those are enough for you for the examination. Okay, if you practice that questions, means you will get the confidence. Clear? So that is about here nomenclature part. And what is the next important point we are having? Means here isomerism. Isomerism. So what is mean by the isomerism? So before going to the isomerism, okay. So first I'll complete the isomerism a little bit. Then we have some other terms are there. So that we will check it out. So what is mean by the isomerism? So here I want to discuss only structural isomerism. I don't want to discuss here only structural isomerism. So what is mean by the isomerism? The isomerism is nothing but 2 or more number of compounds are having same molecular formula, but differ in their any one of the physical or chemical property, any one of physical or chemical property of the compound. Chemical property of the compound, okay, of the compound is called as isomerism. What is meant by the isomerism? Means here 2 or more number of compounds are having, okay, so same molecular formula but differ in that any one of the physical or chemical property of the compound is called as a isomerism. Okay, sir, why they'll exhibit as a different physical and chemical properties? Means based on the arrangement. So if they're having different structural arrangement, means here they exhibit as a different physical and chemical properties. Okay, based on this one, again isomerism is classified into 2 types. So one is called as a structural isomerism, another one is called as a stereoisomerism. So first one is called as here structural isomerism, second one is called as a stereoisomerism. Okay, Sir, what is mean by the structural isomerism? Let's see, this concept is applicable for whole organic chemistry. So what are the chapters you are studying under the organic chemistry? In all the chapters, we are studying about the isomerism. Okay, sir, what is mean by the structural isomerism? What is mean the structural isomerism means here? Compounds are having two or more number of compounds are having same molecular formula but differ in their structural arrangement is called as a structural isomer, and the phenomenon is called as a structural isomerism. Sir, what are the examples of the structural isomerism means here? Again, structural isomerism is classified into different types. In that one, first one is chain isomerism. Chain isomerism. Okay, sir, what is mean by the chain isomerism? So chain isomerism is having same molecular formula. For example, I'm taking as a pentane. What is the molecular formula of the pentane? Means C5H12. C5H12. Okay, let us see. So here in pentane, N-pentane means I can write as a like this: CH3 bond, CH2 bond, CH2 bond, CH2 bond, CH3. So this we can call as a N-pentane. So what is mean by the N-pentane means if all carbon atoms are present in a straight line is called as a N-pentane. So what is mean the N-pentane ma? If all carbon atoms are present in a straight line is called as a N-pentane. Got the clarity? Okay. So this is a common name here. And isopentane. Sir, what is mean the isopentane means here? So last but one carbon atom. So that means this is the last carbon atom. The last but one carbon atom is this one. If this carbon atom is attaches with the one methyl group is called as isopentane. CH3 bond, bond, CH3, H, bond, CH2 bond, CH3. Okay. So this we can call as a isopentane. This we can call as here isopentane and neopentane. So what is meant by the neopentane means last but one carbon atom is attaches with. So two methyl groups is called as here neopentane. Okay, this we can call as a neopentane. Now once you check it out, so what's the difference between the first one, second one, and third one? What's the difference you observe? N-pentane, isopentane, neopentane. What difference you observed in that one?
Their structures.
Structure. Okay. So in structure also what means here chain length. If you see in the first structure, all carbon atoms are present in a straight line. Okay. Second carbon atom, second molecule. In second molecule in a straight line, we have only 4 carbon atoms. And third one, if you observe, means in a straight line, we have only 3 carbon atoms. Okay. So, but all our formula is same. For all these 3 formula is same. What is the formula? Means C5H12 also. You can check it out. How many number of carbon atoms, how many number of hydrogens are there. Okay. Sir, what's the difference means here? All these 3 are having same molecular formula but differ in their chain length. So all these 3 are we can call as a chain isomers, and the phenomenon is called as a chain isomerism. So based on this one, we can explain one physical property also. Which physical property we are going to be explaining means here boiling point temperatures. Actually, boiling point temperatures are depends upon the surface area. Boiling point temperatures are depends upon surface area. If the surface area is increases, their boiling point temperatures are going to be increases. Okay. So according to that one, so in N-pentane, isopentane, neopentane, which one is having the greater the boiling point temperature? N-pentane, neopentane, sorry, N-pentane, isopentane, and neopentane. Neopentane. So which one is having the greater the boiling point temperature? Make it fast. First, second, or third. This type of questions also is there. That's why I'm asking. The first one is having the greater the boiling point temperature. After that, second one. After that, the third one. Sir, why means here if the carbon chain length is decreases, boiling point temperature also is going to be decreases. Okay, so there is a physical property of the difference. Sir, clear?
Yes, sir.
Right. Next, position isomerism. Next one is here, position isomerism. Position isomerism. What is meant by the positional isomerism means here, compounds are having same molecular formula, but differ in their position of the substituent, position of substituent or functional group, position of the substituent or functional group is called as a positional isomerism. Sir, what is the example means here? For example, let us see, we can write as a CH3 bond, CH2 bond, CH2 OH. Sir, actually, what is the IUPAC name of this one means here? 1-propanol, 1-propanol, propanol, 1-propanol. Alcoholic suffix of the alcoholic functional group is OL. Okay, suffix of the alcoholic functional group is here OL. So hence we can write as a 1-propanol. Sir, why you are writing as a 1-propanol means here alcoholic group is attaches to the first carbon atom. Alcoholic group is attaches to which carbon atom? First carbon atom. So that's why we can write as a 1-propanol. This also we can write. Let's say slightly I'm modifying the structure. If slightly I'm modifying the structure means CH3 bond, CH bond, OH bond, CH3. CH3 bond, CH bond, CH3 bond, OH. Okay. Now once you check it out here, what is the IUPAC name of this one here?
Propane to all.
Propane to all. Very good, ma'am. So propane to all. So what is the difference it is there in these two means here? Position of the functional group. Both are having same molecular formula only, but differ in their position of here. Functional group is called as a positional isomerism. Differ in their position of the functional group is called as a positional isomerism. Okay. Next, functional isomerism is there. Functional isomerism. What is the functional isomerism? The compounds are converted from one functional group to another functional group is called as a functional isomers. Both are having same molecular formula but differ in there. So they convert from one functional group to another functional group. Sir, what are the examples means? For example, carboxylic acids are there. Carboxylic acids. Carboxylic acids are converted into esters. Carboxylic acids are converted into ester. Okay. Alcohols are there. Alcohols are converted into ethers. Alcohols are converted into ethers. Aldehydes are converted into ketones. Aldehydes are converted into ketones. Okay. And carboxylic acids here. Cyanides. Cyanides are converted into isocyanides. Cyanides are converted into isocyanides. So all these are the different examples of the functional isomer. Okay. So both the compounds are having same molecular formula but differ. They convert from one functional group to another functional group is called as a functional isomerism. Sir, what is the best example for this one means here? I can take alcohol only. Okay, so what you are telling that I can write as a propanol. What is the molecular formula of the propanol? CH3 bond, CH2 bond, CH2 bond, OH you wrote as here. Okay, this also I'm writing as a CH3 bond, CH2 bond, O bond, CH3. OR group is called as a ether functional group. This only we can call as a ethyl methyl ether. Ethyl methyl ether. So this it is converted into ethyl methyl ether. So this we can call as a propanol alcohol. This we can call as a propanol. Clear? And another one, metamerism. So what is another isomerism means here? Metamerism. Metamerism. Sir, what is meant by the metamerism means here? So compounds, two or more number of compounds are having same molecular formula and same functional group. Same molecular formula, same molecular formula and same functional group same functional group, okay, having same molecular formula and same functional group, but differ in their carbon chain length, chain length attaches to the same functional group, attaches to the same functional group, same functional group is called as a metamerism. Sir, what is the example? Means we can take as a diethyl ether. What is the molecular form of the diethyl ether? C2H5 bond, O bond, C2H5. If you see my right side and left side, so both are having equal number of carbon atoms. And these also we can write as a CH3 bond, O bond, CH2 bond, CH2 bond, CH3. This we can call as a methyl propyl ether. Sir, what's the difference it is that means here? So here in the first structure, left hand side and right hand side, we have a two carbon atoms, but functional group is same only. But here also functional group is ether functional group only. But right hand side we have a 3 carbon atoms, left hand side we have only 1 carbon atom. Okay, both are having same molecular formula, but differ in the number of carbon atoms which are attached to the same functional group is called as a metamerism. Got the clarity?
Yes, sir.
So these are the different structural isomers we are having. Okay, so these are the different structural. Actually, deleted portion one more it is there. So tautomerism is not there, but tautomerism, based on the tautomerism, still nowadays also they're asking the questions in the JEE level and NEET level also. So what is mean by the tautomerism? Tautomerism. So what is mean by the tautomerism? Tautomerism also we can call it as a ketoenol tautomerism. Ketoenol tautomerism. Sir, what is mean by the ketoenol? Means first I am taking as a ketone. I am taking as an acetone. CH3 bond, C double bond O bond CH3. Let's see ma. Here at ketone functional group, adjacent carbon is called as a alpha carbon. At alpha carbon atom, how many hydrogens are there? How many hydrogens are there at alpha carbon atom?
3.
3. In that one, if the one hydrogen atom is shifted towards to the oxygen, that time actually in between the carbon and oxygen we have a double bond now. In that one, that pi bond is shifted in between the carbon and carbon. If it is shifted in between the carbon and carbon, means you will get as a CH3 bond, C bond, OH, double bond, CH2. Okay, in between these two, if the equilibrium is going to be exist mean, that is only we can call it as a tautomerism. And first what I wrote here, first one I wrote as a ketone. Okay, ketone. And second one, what is the product you got? If you see the product means the product is containing alcoholic functional group and unsaturated. What is the suffix of the double bond? Suffix of the double bond is nothing but ene only na. Okay, and suffix of the alcoholic functional group is nothing but here OL. So that's why this is also we can call as a ketoenol tautomerism. So what is mean by the tautomerism means here one compound is easily interconvertible to another compound by existing dynamic equilibrium is called as a ketoenol tautomerism. Got the point here?
Yes, sir.
Okay, so they're giving some structures. They're giving some structure, and which of the following is exhibit as a tautomerism and at all, they're asking the question. That kind of questions are there. Okay, so this is about here isomerism. Okay, so remaining part we will continue in the next class part. But tomorrow you have a test. Already I uploaded the paper also. So based on the thermodynamics and equilibrium, based on these 2 chapters only, I had given the test. Okay, once
Okay,
I'll complete this chapter also, based on this chapter also, you are going to write the test. Full chapter.
Okay, sir.
Okay. So in that one, most probably MSET level questions only it is that MSET and slightly NEET level questions also it is there. Okay. So once you try your level best. All the best.
Okay, sir. Thank you,
Okay,
sir.
right. Yeah, you're welcome. We'll continue in the next class.
Thank you, sir.
You're welcome.